Hi, this is Group 8, and today we are looking at the performance pattern FastPath. The Gang of 4 use an example of the proxy pattern that illustrates how it could be used to implement FastPath. Imagine you are making an editor for documents containing both text and images that are stored in different locations. Opening a document may not be the most commonly used function, but if it takes too long, users won't choose this editor. Thus, this function is a candidate for FastPath. One way to try and implement FastPath to solve this issue is by only loading graphic images when they first become visible. This will save considerable time when opening the document by having most images not be visible right away. In order for this to be a viable option, though, the editor needs to still know the size of the images. The proxy pattern allows us to accomplish this. The figure here illustrates this. The editor interacts with the image proxy object, which acts as a temporary replacement for the actual images. The image proxy provides the editor with sizes of the images so the editor can properly format the document. When the image is ready, image proxy calls a draw request to put it in the document. FastPath works by reducing the required processing time on heavier workloads to improve response time. FastPath focuses on finding which choices a user will make and giving it priority. This might mean that when the user is faced with a list of options, the more commonly chosen response will be displayed first. When this same concept is applied to an application with a large number of functions, the same problem occurs. For example, an ATM provides many options to the user, such as deposits and purchasing postage stamps, but far and away the most common use is for withdrawal. These important functions can have significant impact on the performance of the system. To avoid these problems, the processing time for these common functions should be minimized. For example, this would mean reducing the withdrawal function into buttons of predetermined amounts. This ATM example is one way to implement FastPath. It allows the user to press one key to select a predetermined withdrawal amount without needing to go through multiple unnecessary menus. In the future, some systems might even allow the user to withdraw the quote-unquote usual amount. Another way to implement FastPath is by minimizing the number of windows needed to complete an end-to-end task. Some websites even make the mistake of putting certain functions behind multiple pages when having a button for it on the home page would take significantly less time. A third way to implement FastPath is to realize that some data might be required by the system far more often. For example, prices for the most commonly traded stocks should be cached. There are many benefits to using FastPath. Using a FastPath reduces the response time on important functions by reducing required processing. It also reduces the load on the system by avoiding some resource consumption. This can also improve the response time of other functions as well. However, there are also many consequences to using FastPath. When using FastPath, you not only have to recognize the need for it, but ensure it is likely to be used. For example, if an ATM uses buttons for quick withdrawing money, but only selected amounts that no user would need to withdraw, Usage patterns can also vary depending on the system, which can negatively impact FastPath.